So this is day 11 review. The last review sheet 4, focuses on the most recent stuff. You got things like average value, volumes of solids, arc length, surface area, and you got the setups for all of those right on the front. So today you're doing number 1 through 7, and we're going to do 2, 3, and 6 together. So we'll start off on number 2. So we want to find the area under the curve geometrically. If it says geometrically or using area formulas, that means our graph should create an area between the graph and the x-axis that is just nice formulas. So triangles, rectangles, portions of circles, things like that. So we want to recognize this as the top half of a circle. If we squared both sides, that would give us y squared. And then add the x squared over, we get x squared plus y squared equals r squared. And that's a little more familiar looking as the equation of a circle. So this is a circle with radius r, but only the top half, because really the square root would have a plus and minus. So we've got minus r to r. And we want to find all that area. Well, it's just half a circle. So we just have 1/2 pi r squared. And that's it for this, because we had the general r. But if, say, that r squared had been like a 25, we would have 1/2 pi 5 squared. If it was 16, 1/2 pi 4 squared, and so on. Next up, area between curves. When you do area between curves, you want to graph it, and you just do integral of top minus bottom if you're in terms of x's, or integral of right minus left if you're in terms of y's. So to graph this, let's start out, let's set them equal to each other to see where they intersect. So if we bring everything over to the left, we'll get a minus x and a minus 2. This factors into x minus 2 and x plus 1. So setting those equal to 0, we get x equals 2 and x equals negative 1. So our t-chart, we'd want to go from negative 1 to 2. So like the easy ones, if we sub in 0, we get back 1. Here, if we sub in 0, we get back 3. These ones are all pretty easy, because then we're just changing by 3 each time. So this gives us 6 and 9, and this would give us 0. Over here, if you sub in 1, you'd have 1, 2, 1, so we get 4. If we sub in 2, we get 4, 4, 1, so we get 9. And if you sub in negative 1, you get 1 minus 2 plus 1, so we get 0. So we'll now be able to graph this. We got to make sure we can get up to 9. Make this one be blue. And we'll make this one be red. And the main reason for this graph is to determine, we're in terms of x's, so which one is top and which one is bottom. So notice we have line on top and the parabola on bottom. So our setup, our integral is going to be from negative 1 to 2. We will have 3x plus 3 minus, make sure you put the second thing in parentheses, x squared plus 2x plus 1, and then dx. Okay, so again, that was top minus bottom we did. If it was in terms of y's, we'd do right minus left. So we'll start out by just distributing our negative. Oops, I forgot the 1 here. So we have minus x squared plus x plus 2. So our antiderivative, negative a third x cubed plus 1/2 x squared plus 2x from -1 to 2. If we sub in 2, we'll get negative 8/3. If we sub in 2 here, we'll get 2, and then 4, minus start a parenthesis. -1 subbed in will come back as a -1 times the -1/3 will be positive 1/3. -1 subbed in here will come back as a positive 1 times the half. And then -1 times 2 is -2. Combine like terms with the ones that already have the same denominators first. So negative 8/3 minus 1/3 is negative 9/3, which is really just -3. And then -3 and 2 is -1, plus 4 is 3, plus 2 is 6. So we've got 6 minus a half, and that would give us sorry, not 6, 5. 5, because -3 and 2 is -1, plus 4 is 3, plus 2 is 5. So that would give us 4.5, or in other words, 9/2. And that represents the area between the two curves. Now, if you're doing an area between curves or you're doing a volume, those should always come back as positive numbers. If you get something that's not positive, then you know you did something wrong. And then we'll also look at question 6. So we've got these two equations. We get an area bound by them, and we're going to go around y equals 3. So we'll start out, set them equal to each other, which will help us draw the picture. Maybe we'll get everything over to the right, so we have a positive x squared. And the 6's will wipe out. So we can pull out an x. So we get x equals 0 and x equals -3. All right, so maybe we'll start the line first. We'll do that as the second one. That's the easy one. We just have 6, 7, 8, 9. Over here, we'll get 6 when we sub in 0. When we put in 1, we'll get 6 minus 2 minus 1, so we get 3 back. When we put in 2, we'll have 6 minus 4 minus 4, so we get -2 back. And when we put in 3, we'll have 6 minus 6 minus 9. Oops, sorry, I messed up those tables. I went the wrong direction. Okay, the reason I knew it was wrong is I got -9 here, but I got +9 there. So I knew something was off. Let's fix that. So we're going -3 to 0. So again, the line is the easier one. So at 0, we're at 6. When you put in -1, we get 3. Then we've got 0 and then -3. When you put in -3 here, we'll have 6 plus 6 minus 9 So we get 3. I'm sorry, I messed these two up here. Or these 3. I don't know what I was thinking. Negative 1 plus 6 is 5. Negative 2 plus 6 is 4. Negative 3 plus 6 is 3. Sorry about that. Negative 2, when you fill it in, you'll have 6 and 4 is 10. And then we'll have minus 4. So we'll have 6. Negative 1, when you put it in, we'll have 6, 2, and minus 1. So that's going to give us 7. And then when you put the 0 in, you get 6 back. All right, we should be in good shape now. Got to make sure we get up to 7. All right, we'll make this one be red. So we got 0, 6, negative 1, 7, negative 2, 6, and negative 3, 3. And over here, we may make this one green. So we got that there. And we want to go over the line y equals 3. So disks is ruled out because there's gap in between. Washers will work because the outer function is consistent, the inner function is consistent. Shells will not work because if you draw the slice parallel to what we're rotating around, in this red part here, the slice would be hitting the same function on either side. So washers is our only option here. So we have pi integral. When you do washers, you slice perpendicular to what we are rotating around. So when you slice this way, we're slicing the x-axis. So you got pi, some radius squared, and we're dx. So our x's are going from 0, or sorry, negative 3 to 0. So here is our outer radius, here is our inner radius. Think of it just like area between curves. So for this outer radius, we just got to do the top minus the bottom. Now what I mean by that is this purple line for the outer radius, where the top edge of it is at the parabola, the bottom edge of it is at y equals 3. So you're just going to do top minus bottom. So in other words, parabola minus 3. So if we do the parabola minus 3, that would give us 3 minus 2x. I'm going to have to make my parenthesis bigger to fit the minus x squared. For the inner radius, again, you're doing top minus bottom. So here it's the green line minus the y equals 3. So if we do this line minus 3, we'll get x plus 3. So this one is going to be a little bit of a pain to multiply out. Because we've got 3 minus 2x minus x squared times 3 minus 2x minus x squared. So if we distribute the first 3 through, we'll get 9 minus 6x minus 3x squared. If we distribute the negative 2 through, we'll get negative 6x plus 4x squared plus 2x cubed. And if you distribute the negative x squared through, you'll get negative 3x squared plus 2x cubed plus x to the fourth. Now let's just, at the same time, x plus 3 FOILed out would be x squared plus 3x plus 3x, so plus 6x plus 9, and then we'd have to distribute the negatives. So we'd have minus x squared minus 6x minus 9. And that's all of that done out and the negatives distributed. So now we can just focus on combining like terms. So our biggest thing we have of pi negative 3 to 0, our biggest thing we have is an x to the fourth, which we only have one of. Then we have a 2x cubed and a 2x cubed, so that's plus 4x cubed. We got 4 different x squared terms. We have negative 3x squared plus 4x squared gives us 1x squared. Minus 3x squared gives us negative 2x squared. Minus x squared gives us negative 3x squared. Then our x's, we have minus 6x, minus 6x, and minus 6x. That gives us negative 18x. And then the 9's wipe out, because you got 9 minus 9. So we are ready for our antiderivative. 1/5 x to the 5th plus x to the 4th minus x cubed minus 9x squared. And that's going from negative 3 to 0. Now, there's a common mistake people make here. We got to be real careful. So when we sub in 0, we get 0, but then it's minus and whatever we get back for the negative 3. So negative 3 to the 5th is going to come back negative. So we'll have negative some number over 5. 3 cubed is 27, times another 3 is 81, times another 3 is 243. So we got minus 243 over 5. Negative 3 to the 4th will be a positive. 3 times 3 is 9, times another 3 is 27, times another 3 is 81. Negative 3 to the 3rd is negative 27, but then it's negated, so we have plus 27. Negative 3 squared is 9, times a negative 9, we have minus 81. So if we distribute our negative and combine some things, we're just going to have 243 over 5. The 81s wipe out. And then we're going to have a minus 27. Well, let's make the 27 be over 5. 5 times 20 is 100. 5 times 7 is 35. So we're going to have 135. So that would end up giving us 108 pi over 5. I said 8, but I wrote a 5. 108 pi over 5. And that is our volume. That we get when we rotate that region around y equals 3. Keep in mind, volume should always be positive, so if you get something negative, you know you did something wrong. All right, so you're finishing the rest of 1 through 7.